Good afternoon. I'll try to keep it brief. I know everybody's probably getting tired, getting hungry. Thanks for inviting me to speak. As she said, I'm John Matthews, the director of Trenchless Technology Center at Louisiana Tech, way over in the U.S. And so Ian did a great job talking about sewer lining technologies. What I'm going to focus more on are technologies used for pressure pipe, primarily for water distribution pipe. You'll see some similarities to what both Ray and Ian discussed. And I'm going to hit them real fast, just kind of at a high level. So talk a little bit about why we do water main rehab and some benefits and disadvantages to each technology, and then I'll wrap it up really quickly, okay? So when you're dealing with pressure pipe, your failure mechanisms come from within. So typically when pipes fail, they burst, they leak first, and then they can have very violent bursts. You see here a very large bar wrap concrete pipe where the bars had corroded and then it had extreme violent break. And when you have these things, can lead to very large sinkholes. It's quite dangerous. Obviously, these are extreme cases with large pipes. We also have very small pipes. When they fail, it's less consequential, but we'd still like to replace them. So there's quite a few techniques out there that are available for fixing them. One thing I do want to leave you all with today is some references and some things if you want to learn more besides going to the exhibit hall. There are a few freely available reports on the U.S. EPA website that several of us, Ray and Deck and many others, worked on years ago, but there's still a lot of great information in there about capabilities of some of these techniques, specifically for pressure pipes. So there's a state of technology report covering many of these techniques in a lot more detail. And then there was a couple demonstration projects we worked on where we tried some new techniques to see how well they work. So I think I have a link to that website here at the end. So when we talk about techniques, the first one that Ray actually talked about using on sewer was actually developed for pressure pipe, right? He mentioned for British gas, and it's actually used quite commonly for repairing small diameter pressure pipes. So you can go in, and as Ray showed, you can break up the old pipe and you can pull in a new pipe at the same time, typically some type of thermoplastic pipe, PVC or HDPE, but you can use other materials as well. And one of the big benefits is you can actually make the pipe bigger. So without having to excavate, dig an old pipe out, and put a bigger pipe in, you can actually pull a bigger pipe in as you're bursting. And so it's a huge benefit. All the other techniques we're going to talk about, it's not possible to increase capacity. So it's one of the unique benefits of pipe bursting. And as Ray mentioned, this is really a replacement technique. So you're actually pulling in a completely independent pipe. So it can be designed to withstand all loads, external and internal. So big benefit. One of the limitations, though, Ray, I don't remember if you talked about this. Typically, though, if you have water services coming in, right, going to your buildings and houses, you typically have to excavate at those to reinstate. So it's trenchless. It's not completely no trench. So you do have to go in and do some service reinstatement. So one of the limitations. A comparable technique, I think Ray highlighted it or mentioned it but didn't talk about it, very similar to pipe bursting, except instead of breaking up the old pipe and expanding it in the soil, just putting a smaller pipe within a larger pipe. So not what Ian talked about with CIPP. I'm going to get to that in a second, but there's various different ways to take a pipe and either temporarily reduce the diameter and then insert it into a water main and then let it expand back up. Or you can just install a pipe that is physically smaller inside of a host pipe, and then you can grout the outside similar to the spiral outlining. And again, a benefit with this is you can technically get an actual pipe inside of your pipe. Now it's going to be smaller, right? You're going to lose some capacity. So you need to make sure that that's allowable. But other than that, as long as you're willing to sacrifice the capacity loss, you can get a fully standalone pipe within an old pipe. Slip lining, probably one of the oldest rehabilitation techniques around. We took a visit to Talon Water over the weekend, and they showed one really old picture where they had done some slip lining many, many years ago. So it was very interesting to see that even over here. Again, one of the limitations has to do with reinstating service connections. So if you're in a residential area where you're feeding a lot of service, you typically have to excavate at those services. So Slip lining tends to be more beneficial when you have long stretches of relatively straight pipe where you don't have a lot of service connections and you don't have a lot of bends. And when you're dealing with pressure pipes, you do tend to have more bends than with sewers. Sewers tend to run on grade, not always, but most of the time. Water mains, since they're under pressure, they can kind of go a little bit all over the place. And so you can do some bends with a slip line, but the straighter, the better, typically. And you can go longer distances. You can go much farther. The next technology I want to talk about is very similar to what Ian just mentioned, CIPP, used for sewers. It has been modified now to where it's, I would say commonly, but can commonly be used for water main rehabilitation. One of the main differences when you're dealing with a sewer CIPP or a water CIP is water quality, right? So we drink water out of water mains. So they use different resins to make that hard liner that Ian showed. They use resins that are safe to interact with drinking water. The ones that are used in sewers are not safe, which doesn't matter, right? Because we don't deal with sewer water once it's disposed of, but drinking water is very important, right? So anytime, and that's the same for bursting or lining, any type of lining, whatever coating or liner you use that's going to interact with that water must be safe for human consumption. So some of the benefits here, you can design these liners. So we're not putting a new pipe in there, right? We're building a liner inside of the pipe. They can be designed to be fully structural, withstand all internal and external loads. They can also be designed to be interactive. Now, one benefit compared to what we talked about with bursting and slip lining is you don't have to excavate when you're, in general, you don't have to excavate when you're reinstating those services. If you go down to the exhibit hall, they have some robots that they'll actually send down in the water mains that you can reinstate services robotically with just a little cutter. So that's a big benefit. In general, this technology tends to be a little bit more expensive than the other techniques, but then you see this benefit here, and it can help offset some of that cost. In general, the liners are relatively thin. They're strong but thin, and so it's not like slip lining where you're losing quite a bit of capacity. The capacity loss is much less. And typically, because you're going in and cleaning out that pipe at first, you're generally actually improving your hydraulic characteristics. Some of the limitations, you can't do as long a reach. I know these are in feet, but maybe 100, 200 meters might be normal for a max, whereas with slip lining, you can go quite a bit, 500 meters or even farther. Sometimes if there's multiple bends, like multiple weird configurations, which does happen, you may have to add some additional excavation pits, access pits. But in general, they can navigate these liners because they're soft when they're going in. They can navigate relatively complex bend conditions pretty well. There is a tighter cleaning requirement for these liners versus like a pipe burst. You don't really have to line as long as you can get a cable through a tension winch to pull back. You should be okay. But with CIPP, you need to have a relatively clean surface. It doesn't actually adhere chemically to the hose pipe, but it typically has a mechanical adhesion, and so it needs to be relatively clean. Another technology that's sort of made its way from structural engineering. Do we have anybody studying structural engineering in here? Okay. The use of carbon fiber reinforced polymers has been used for quite a while to reinforce structural components like columns and beams, and eventually made its way to reinforcing exposed pipelines from the outside. So just wrapping those with a series of layers of resin and carbon fiber that when it hardens, it's quite strong. We know carbon fiber is relatively strong for its weight. And so it provides quite a bit of additional structural carrying capacity. And so, as always happens, eventually it made its way to inside of pipes. Of course, you see this is a relatively large pipe. You couldn't use this in just any old small pipe because you do need person access and needs to be safe working conditions. But if you can allow it, it kind of looks like wallpaper, just like putting, which I know wallpaper is not so common anymore, but putting wallpaper up, just applying your resin and then layering in the the fibers, and you can run the fibers in multiple directions, and you can add quite a bit of strength. So this is more of a spot repair location, spot repair technology where you can go through a pipe and assess it. And you saw that pipe I showed earlier that was exploded that had all those fibers on it. That's not something for this technology. But if you were to assess that pipe first and say, well, there's a couple sections where we have a few broken bars and we don't want to get to that point where we have a big explosion, you may go in and sort of surgically just repair certain sections with something like this, a carbon fiber repair. So again, very strong. You can custom fit it, but it needs to be a really large pipe, and it's really just a spot repair technique. It's not something you would commonly use to repair an entire 200, 300, 400 meters of pipe. It's too expensive for that. So just a couple more techniques I'm going to throw in there. Another spot repair technique that, again, we use for large diameter pipes, and we really just use it to control leaks at joints and seal joints as they start to leak over time. It's called joint and spot repair. So you see here, this is just a rubber gasket, and then you can sometimes you can grout them in. Most of the time they'll put like a steel band on them, and that band will apply the stress, the pressure to hold it in place. And it doesn't add any strength to the pipe. It just keeps the water from either going out and coming in. And so in this case, we're trying to keep water from going out with pressure pipes. So it has a lot of benefit. Typically, it's used in combination with some of the other techniques. Maybe they'll seal the joints before they go through in line or something like that, or they'll just use these at the end seals. But it's a custom fit, so you don't have to worry about service connections, and it can seal your joints and pinholes. But limitations, again, just person entry. For the most part, there's a couple little smaller little ones that can go into pipes, smaller pipes now. But it's non-structural. It's not adding any additional strength to that pipe. The last one I'm going to talk about is one that we've done a lot of development and testing on over the years, and very recently in deck as well, is spray-on coatings. Ian mentioned spray-on coatings, specifically cementitious, been around forever. And even in water mains, spray-on cementitious coatings have been used for quite a while just to improve water quality. When you have metallic pipe, you can have different chemical reactions go on. You can get red water and things like that. And so cementitious coatings have been used for a long time, but over the last, 15, maybe 20 years, we've started to see some innovations going with polymer coatings. So different polymerics, polyurethanes, epoxies, polyureas, and they're still developing. There's still some improvements that can be made. But we're very excited about the possibilities of these techniques becoming more cost effective and potentially used quite a bit more. So one of the benefits, you don't typically have to worry about reinstating services. So there's no excavation. There's typically not even a mechanical or physical reinstatement that needs to take place. Currently, they're mostly only used to span holes and gaps and not really a fully structural solution, although there's some recent developments there. And with some of the new blends like the polyureas, they cure really quickly. In fact, they set in seconds. You wouldn't turn the water back on in seconds, but they set really, really quickly. And so that's a big benefit to some of the old coatings that took several hours or sometimes days to fully get hard. Some of the potential limitations are the cleaning requirements, just to make sure you get a good adhesion. Some require adhesion, some do not, most do. There's still some tricky things that happen because most of these are done robotically. So they have a small robot that'll go in, and if you can imagine, as that robot it's making its way, it tends to spray a little bit uneven. It's hard to spray a very constant thickness. So there's been quite a bit of robotic development in the U.S. specifically in this area over the last 5 years. That's maybe going to make its way up to an advantage, but still currently sitting in the limitation. Same thing for structural claims. Our staff at TTC probably spend a couple days a week working with multiple manufacturers on this issue here specifically. So it's something that several companies are trying to tackle. So that's kind of the big picture of the different techniques that are available. And I know Ian threw up a quick slide there about, the important things to understand if you're going to try to choose something. So I just wanted to throw this up so that you could kind of tie it back to the limitations and benefits that we talked about for each one. So if you have a pipe, does it still have structural carrying capacity? Meaning maybe it's just leaking, but in general it's withstanding all the loads. Or do you have a pipe that's on the verge of collapse? So that might lead you towards one technology versus another, right? If you just have a leak, you focus on that. If you have a pipe that's about to explode, you're going to need to apply some additional structural capacity. Do you have a lot of service and branch connections, or just a very few? We talked about the benefits of some technologies there. Is your existing flow capacity good? Do you need more, which means it's bursting or open cut? Or can you use less? Maybe slip lining is okay. Accessibility is always an issue, but specifically when you're dealing with those person entry pipes, safe working conditions are very important. Proper ventilation, confined space entry, all those things need to be taken into account. And also, some of these techniques we talked about, they're not readily available everywhere. So what is the availability of contractors and timing in the area where you need them? That's important. You can't just say, I want to do this and have to wait on a contractor to come from another country, another state, because that's going to increase your costs, right? So you need to take that into account. And then in general, every technology, right, has some limitations. I didn't want to go into any technical numbers, but has limitations on diameters they're comfortable with, lengths, and things like that. So these are some of the main factors you would want to consider when trying to think about which technology you want to use. So if you want more information, like I mentioned, there's great resources from the EPA. They're somewhat dated now, but most of that information is still good. And like Ian said, you can get brand new information downstairs today, which is fantastic. You can always reach out to us or ISTT or NASTT, which are two of the main organizations promoting trenchless worldwide. UKSTT as well, that Ian's part of. Hopefully you can get a copy of the slides. Yes, or a copy of the videos. Yeah. So you'll have all these references, and there's my contact information. If you ever have a question, we work with technologies all the time, manufacturers, and all kind of stuff. So I'd be happy to share with you all what we got going on. So that's my email. Feel free to reach out, and I'll take any questions if you have any.